Today we are going to multiply and divide rational expressions. Now, when you were working with them yesterday, one of the things they asked you to do was to identify where the function was undefined or the expression was undefined. And with these multiplying and dividing ones, we are not going to do that. We'll come back and talk about them tomorrow because we're actually going to have we're going to work on this more tomorrow too, this and what you were doing yesterday. So, multiplying, simplify your answer. All right. So we want to multiply the numerators and the denominators, and we're going to factor them and arrange them so like variables are together. And then we'll simplify by canceling like factors, which is what you were basically what you're doing last night. The biggest thing is that whenever you see expressions that are binomials, like there are here in the upper left and the lower right for letter A, then we want to factor first of all if we can. All right. So it says to multiply them, and so basically when I say to multiply them, we want to just get rid of the multiplication sign and just going to have one fraction bar. But then we're going to factor. So here we have, we'll rewrite this one as 4 times c minus 1 in the numerator. All right, put it so that the constants come first. Then in the denominator, I've got 2 times, and I'm always looking to factor if I have binomials or trinomials. Well, 3c minus 3, they have a 3 in common, so I'm going to factor out a 3. All right, and then I'm left with c minus 1 when I factor out that 3. So now I'm looking for common factors in the numerator and the denominator so that I can cancel. And so since I have c minus 1 and c minus 1, I can cancel those out. And a reminder that when I cancel them, that still means that they go into each other once. Right? So that there's still a 1 there. And then I can also, 2 goes into 2 twice, 2 goes into 4, or 2 goes into 2 once, 2 goes into 4 twice. So we can cancel the 4 and the 2, or with the 4 and the 2. So what do I have left? In the numerator, I have a 2. In the denominator, we've got 1 times 3 times 1 is 3. So this is just 2/3. When we're multiplying monomials together. In this case, there won't be any factoring that goes on, but we are going to multiply first, the numerator and the denominator first. So I want to simplify the expressions the best I can before I actually do any canceling. Now, some of you might be able to go through and cancel right now. It ends up a little bit more of a mess. So we're actually going to do the multiplication first. So 8 times 10 is 80. And don't forget, when you multiply with the same variable, you add the exponents together. All right. So let's say I have x squared here. I have no other x's, so we have x squared. We have a y cubed here and a y squared there. So I'm multiplying same base. So I add those exponents. So that's y to the 5th and z squared. There's our numerator. All right, so we multiply the constants together, multiply any variables together, and add their exponents if they're the same. All right, the denominator, 5 times 16. All right, that's also 80. And I don't have any x's, but I have a y here and a y here. That's y to the 4th. and z squared. Right? And you see I wrote them over, or put them in, lined them up by their like terms. So now I can cancel. Right? So the 80 goes into 80 once, so I can cross those out, and I have a 1 for each of them. So I'm going to put a fraction bar here. This will help me. Right? X squared, there's no other x's, so I've got x squared is going to go in the numerator. And I have y to the 5th and y to the 4th. What do I do with the exponents then? Yeah, we subtract them, okay? So 5 minus 4 is 1, so I have 1 left in the numerator. And then both the z's are z squared, so those are going to cross out. All right, and those both give me 1. So basically I have x squared y over 1. Well, I don't need that, so I can just say it's x squared y. So x squared y is my answer. All right, so we multiply and then simplify it. So when you have like variables, when you multiply them, you add the exponents. When you divide them, you subtract the exponents. All right, so go ahead and do this one. Okay, so in this case, once you multiply them, we get 6 times 3 is 18, then r to the 4th, and 35 s to the 4th. Right? And there is no number that goes into 18 and 35. Don't have like variables, so we're done. Nothing else we can do with that one. So that one's done right there. Okay. Can't simplify that any further. Okay, so multiplying. We first look to see if they're binomials or trinomials. We look to see if we can factor them. If we can factor them, then it gives us opportunities for canceling like factors that are binomials. If they're just monomials, like in B and C, then I just multiply across, add the exponents for the like variables, and then simplify it. All right. Or if we have a polynomial, so in here we have a trinomial, x squared minus 6x plus 9 times, a rational expression of 2x over 6x minus 18. Now I put a first note there for these. Make sure all parts are written as fractions. Right. Because I have 6x squared, or x squared minus 6x plus 9, that's not written as a fraction, is it? Okay. What would have to happen for that to be written as a fraction? What do I need? Put it over 1. Okay? So this is actually over 1. Okay? Now, the reason that that's important is because sometimes without doing that, we forget, where does that go? Does that go with the numerator or does it go with the denominator? Okay? Then our next step is we're going to factor. Do any factoring we can do. So we've got x squared minus 6x plus 9. All right. Factors of 9 that add up to 6 be negative 3 and negative 3. So this is x minus 3 and x minus 3. And then we also have the 2x, and I'm going to move that 2x to the front. I prefer to put monomials in the front. Makes it easier for me if they're in front. Okay. The denominator, I have 1 times 6x minus 18. The 6x minus 18, they both have a 6 in common, so we'll factor out the 6, and we're left with x minus 3. So we have it all factored. And now I've got binomials here that I can cancel. All right, I have x minus 3 here, x minus 3 here. All right. Those both leave me with a 1. And I know that 2 goes into 6 3 times. So in the numerator, we're left with x times x minus 3. And in the denominator, we have a 3. So then in this case, I'm going to rewrite that. I'm going to multiply this out. So x squared minus 3x over 3. All right, so first make sure they're all written as a fraction. Factor anything that you can factor, whether it's, if it's a trinomial, factor that appropriately. All right. The binomial, taking out the 6. All right. And then we can cancel like factors. They have to be like factors. All right. So some people, and this is wrong, so this is, I'm telling you about this now, is that sometimes people will try to do this. All right, there's a 1, there's a 3, because, hey, 2x goes into 6x 3 times, right? Okay, that's true, but whenever I put this minus sign here, that's no longer a single piece, all right? It's part of a whole, all right? And I can't get rid of it unless I factor the whole thing. So make sure you don't make that mistake and try to cancel that way. There must be factors to be able to do that. So the only way to get rid of anything from the 6x minus 18 would be to get rid of the whole thing, or factor it like we did, and then simplify it. All right? So you try. So we'll get some more of those. All right? All right, multiplying when everything's contained in polynomials. This is basically the same as that last problem. All right? Just a few more polynomials to work with. But the big thing is we're looking for, all right, if there's 2 terms, do they have a common factor that I can take out? Greatest common factor. If they have more than 2 terms, then can I factor them also? Are they the difference of 2 squares? Or other things. All the things that we factored before, those come into play here. Right? So letter A. All right, then look at the numerator. It says 3a squared plus 6a. All right, well, 3 goes into 3 and 6, and they both have an a. So we're going to take out the 3 and an a there. And we're left with a plus 2. And for the moment, I'm going to put this 3b cubed, just leave it there. Okay. Now, these are my 3 factors in the numerator. Okay. So we look at the denominator. All right, we've got 12b squared. And look at this part here, 3ab plus 6b. What do they have in common? They both have a 3, right? Because 3 goes into 3 and the 6, and they both have b. So I'm taking out 3b from that. And what am I left with? A plus 2. Now this can get a little complicated. All right, you just have to be careful what you're doing. So let's do this first of all. I can see they both have the a plus 2. Oops. So I'm getting rid of the a plus 2. That's obvious part. Okay. Now, there's many different ways to approach the rest of this. All right, you could start canceling things right now, all right, if you wanted to. And you probably do most of it correctly. Okay. What I'm going to do, though, is I'm actually going to multiply these two monomials together, 3a and 3b cubed, and also the 2 in the denominator before I simplify. So 3 times 3 is 9. I have a b to the third power. 12 times 3 is 36. And I just had b to the third power. Right. So how many times is 9 going to 36? Okay. 4 times. So that 4 is in the denominator, because that's where the 36 is. Right? Because it's 1 here and 4 there. Okay. I have b cubed and b cubed. All right, those cancel, because they're the same. 1 there and 1 there. So what am I left with? In the numerator, I have just a. In the denominator, I have just 4. So this is a over 4. All right, so you have to take your time. Make sure you've got everything factored first of all, and then look at them. Now, some of you may have seen this, right? That you could have. I could have done, at this point in time here, I could have said, all right, that 3b cubed, and here's a 3b and the b squared. Okay, I could have got rid of all them right then and there. All right, how many of you saw that? Okay, a couple of you saw that. All right, so if you see that, go right ahead and do it. All right, you don't have to wait till the next part. All right, just giving you options. All right, let's look at letter B here then. A little bit longer one it's going to need some factoring. All right, so a couple things you remember. One is this, before we get into this. All right. P squared minus 16. All right, if I factor that, that's the difference of two squares. This is p plus 4, p minus 4. But we have p squared plus 16, not p squared minus 16. Can I factor p squared plus 16? And the answer is no, you cannot. All right? So here's a reminder why. All right? If I graph x squared minus 16. All right. If I graph that, we have a 0 at positive 4 and negative 4, right? Okay. And that's why I can factor it, because I have zeros. All right. If you don't have zeros, you can't factor. If I change this minus to a plus, all right, it's now the sum of two squares instead of the difference of two squares. Now it does not cross the x-axis because the y-intercept is now up at 16. And so that graph was shifted up. That graph was shifted up so it doesn't cross the x-axis. So the thing to remember is I can factor difference of two squares. I cannot factor the sum of two squares. So, all right, we have p plus 4. Can't do anything with that. Just write it as it is. P squared minus 3p minus 10. All right. Factors of negative 10 add up to negative 3, negative 5, and 2. Denominator. All right, here I have two terms, both have a p in them, so I'll take out the p, left with p plus 2. And then the p squared plus 16, it's the sum of two squares, cannot factor that. All right, so there's really not much we can do here. The only thing we can do here is the common factor in both of them of p plus 2. And I'm okay with you in this situation then leaving it like that. If you want to multiply it, that's fine. I'm telling you, you don't have to. All right, you can leave it written in factored form. Okay. All right, let's look at the division. Okay, so dividing. Dividing is the same as multiplying, right? The only thing is we have to remember to copy, change, and flip. Right? So if A over B divided by C over D, that's the same as A over B times D over C. All right? So we have to remember to copy, change, and flip. All right, we copy down the first fraction, change it to multiplication, and then the second fraction. So 2 over G times G squared over G plus 4. So our steps, write it as a multiplication by taking the reciprocal, our copy, change, and flip. Multiply the numerators and denominators, factor, and cancel only like factors. All right, so here we only have like factor is, we've got a G here, and that G squared becomes just G. So the numerator is 2G, denominator is G plus 4. So copy, change, and flip, factor, simplify. So I start with a copy, change, and flip. Now this is 1 minus n and 1 plus n. All right, this is the difference of two squares. These two have an n in common, so I take out an n. I'm left with n minus 4. So what can we get rid of? Michael, what can I get rid of? The 1 minus n? But this says n minus 1. Are those the same? No, they have to be the same. All right, but we'll talk about that in just a second. Anything else that we can get rid of, though? All right, how about n. All right? It's a factor in both the numerator and the denominator. So I can get rid of the n. Now, with the n minus 1, all right? These two I can get rid of because they're opposites, but what do I need then if I do that? Anybody know? I need a negative sign. All right, because basically what this is, this 1 minus n is actually negative n plus 1, right? And so if I take out the negative, then I'm left with n minus 1. So if they're opposites, like 1 minus n and n minus 1, you can cancel them, but then you're left with a negative. Right? So the answer here is going to be negative 1 plus n and n minus 4. So if you have opposites, 1 minus n, n minus 1, right, you can cancel those, but you're left with a negative because one of them is the opposite of the other. All right, and this last one here. 4xy squared over y divided by 2x squared plus 6x. Now, reminder, this is over 1. That's over 1. So when I copy, change, and flip, right, if there's a 1 in the numerator, and the 2x squared plus 6x is in the denominator. Right. Then I have a binomial here in the denominator, so I need to factor it. 2x squared, 6x, they have a 2x in common. And we're left with x plus 3. So let's see, 2 goes in the 4 twice. Both have an x, so I can get rid of the x. And this y is gone, and I'm left with a y there. So numerator is 2y, denominator x plus 3. So the biggest thing is being able to factor, right? And then being able to cancel correctly, right? Which both are things that you've done before. It's just a matter of putting them together and taking your time doing each step correctly, right? So factor when we can, and you can only cancel common factors. You can't just cross out things because you see an x in the numerator, x in the denominator, get rid of it. They have to be factors for you to be able to do that.